Selamlar.
Merhaba hocam.
Merhaba hocam.
Nasıl yeni yıl?
Bir değişiklik yok şu ana kadar ama
Kutlama yaptınız mı?
Yok hocam. Evde oturduk. Sonra
Anladım. Benim için güzel bir şey oldu. Sabah bizim oyunumuzun prototipi hazırdı. Bir de ben bir Analytics eklentisi eklemiştim. Oyunun yani bizimki kart oyunu ya. İlk başlayan oyuncunun yüzde kaç kazandığını, hangi kartları, hangi desteği oynadığını takip edip kaydını tutmak için ve bunları daha sonra oyun içi dengede kullanabilmek için bir eklenti eklemiştim. İşte 31 Aralık'ta şirket içi bir turnuva yaptık. 16 kişinin katıldığı, 2 de hakemin olduğu. Ben kazandım. Bir
tebrikler hocam.
teşekkürler. Bir hediye çeki aldım 250 liralık. Güzel oldu. Yani hem oyun çalıştı, insanlar beğendi, hem de işte hediye kazanmış oldum. Güzel oldu. Öyle başladım yani. O yüzden benim için en azından yeni yıl güzel geçti diyebiliriz. Şimdi we were left on...
hocam başlamadan bir şey diyebilir miyim?
Tabii.
ALMS'de ödev gözükmüyor hala da onun son günü bugün.
Son günü bugün mü?
2 Ocak, evet 2 Ocak gecesi.
O zaman 5 Ocak mı yapsam? Bakalım. Eklerim ya. Ben sisteme birkaç kez girdim. Sıkıntı olduğunu görünce uzun bir süre girmedim. O yüzden assignment'ları koyamadım resmi olarak. Aslında aklımdaydı. Bakalım. Yani siz hazır mısınız? Siz şu an
Evet hocam.
Evet hocam.
Ekranlar hazır.
size ayıp olmazsa o zaman bir 2 gün daha belki süre verelim de insanlar hani yükleyebilsin yani. Benim hatam olmuş yani. Bir şeye kadar, tatil sonuna kadar şey. Ya ben bu assignment'ın süresini başta kısa tutmamın sebebi şeydi. Az zaman verdim. Oyuna çok zaman kalsın diyeydi. Ama şimdi benden kaynaklı bir sıkıntı olmuş demek ki. İnsanlar itiraz edebilir. 2-3 gün uzatacağım gibi görünüyor o zaman. Süreyi bilginiz olsun yani.
Tamam hocam.
Siz de oyuna daha çok zaman ayırabilirsiniz eğer işinizi bitirdiyseniz. Daha iyi yani bence. Oyun daha kritik. So if there are not any more questions, I guess I can continue with the lecture. Am I sharing my screen or not?
Yes, we can see the screen.
Okay, great. So we were left off when we are talking about movements. We were left off some rigid body movements styles, and I mean, I had a hard time remembering the exact configuration, but after I checked, I realized that I should configure something. So in this rigid body of this character, let's call it character, I mean, you need to freeze rotation in all 3 directions. So it won't be able to rotate. And this will create an effect like this. It's pretty nice. And we can turn by what was the turn commands. So yeah, we can turn rotate by moving the mouse, and we can jump by hitting space button. There's a small bug in this code. So let me just show you. If I zoom out from here, and if just turn it like this. In my code, it checks it checks velocity. Okay, so if you see here, if I'm too fast, it won't accept input from me until I am slowed down. So if this is why my speed is kept at some point. I mean, it does not go beyond this speed, so it doesn't accelerate infinitely. You know, its speed gets to a maximum point and it stops there. But the problem is when you are falling, for instance, like this. I mean, now I hit S, so it should go back. But since you are falling, your speed is bigger than the threshold because of the downwards speed vector, and this is why you are not able to stop. So I mean, I'm not going to change the code because it works in 99% of the situations. Just know that you need to wait to slow down before you give any input. So for instance, let me just show you. I'm going to speed up. Oops. I'm going to speed up, and I'm going to hit A to go left, but it won't accept. Oh, okay. It accepted because it got slowed down too quickly, but I mean, sometimes it does not accept because the forward speed is too high that it does not accept any more inputs. And let's check the code again to remember what we were doing. So this is move with force, use transform rotation, clamp. We also had move with force, use transform rotation script. This has a little difference, and the difference is it clamps the velocity. And like I said, if your velocity is above maximum velocity that we have declared in here and also in the editor here. By the way, if you don't remember what is written in the editor takes precedence, so this overrides what is here. Okay, so if maximum velocity is declared as 20 here and 10 here, then in real life it will be, I mean, Unity will see this as 20. Just keep that in mind. But these are some default values. I mean, if you forget to declare them here, then code will take priority, and code will be used to define what is this variable. But okay, this rigid body velocity magnitude is checked, and this is, I mean, this there's a nice comment line. This checks total velocity vector. So when falling, if you pass this threshold, you won't be able to move. I mean, this is a side effect, but since it's not a huge side effect, and it's kind of logical actually, in real life when you're falling, you can't move. I'm going to leave it as that. And also, what do we have here is some basic inputs that we receive in get key, and we do that in fixed updates. We check this in fixed updates, and since get key can be used in fixed updates, this is okay. if this were get key down, we would have to move it and check it inside update function. But since this is get key, we can check it inside fixed update. And by the way, if you don't understand what I'm saying, you can check the other scripts, and you can check the previous lecture. So some functions should be checked inside fixed update. Normally input functions should be checked inside update. And for some input functions, if you check them outside of the update function, you will receive some errors. But for some functions, such as get key, of course, it's better to check them in update function. But even if you check them inside fixed update, you won't be getting errors. So these are kind of tolerance for your small mistake here. So I mean, you can check them inside fixed update. But okay, so after that little check, you add some force to the rigid body, and you add force by I mean, your force will be determined by moment force, which you declared in the editor and here as well. And this moment force will be multiplied by either transform.forward minus transform.forward, transform.right, or minus transform.right. Since we don't have transform.left, we have to use minus transform.right. And since we don't have backwards, transform that backward is non-existent, we have to use minus transform.forward. Okay. And this creates this effect that I showed you. And we also have a movement. Sorry, we also have a rotation with mouse script. So if we quickly see what is here, we basically have a rotate function, which applies a rotation of some degrees around the z-axis. Also some degrees around the x-axis and some degrees around the y-axis. So this rotate function could be used to turn our object in all three directions, all three rotation axes. I believe this is a better way to say it. And we basically see where our x-axis value of our mouse cursor is, and we give it to this function. We multiply that by turn speed, and this should be the vector that we are turning around. So I mean, let me just show you with something like this. So I mean, this is something that looks up, and our character will turn around this. So you need to give the axis that you want your object to turn around, and this is you also give the how can I say, your reference. So your reference will be the world right now. So this applies transformation relative to the world coordinate system. And there are, I mean, different ways to use this method. You can go check the official documentation by control clicking or command clicking if you are in Mac. And what this method does is applies a rotation of Euler angles around all three axes, and it applies them in that order. So when you give a vector tree of Euler degrees, it takes the x of this vector tree and it applies a rotation in the x axis. Then Euler's dots y will be used to turn our objects around y-axis, and Euler's dot z will be used to turn our objects around z-axis. If you send relative to space.self, then local rotation will be the calculated value from this turning events. Otherwise, for instance, if you used space.world, rotation will be calculated like this. So this method either sets, this method either modifies local rotation or rotation according to the relative to parameter that it's received. So since this is just a specific function, I won't delve into the depths, but you can mess with different parameters and see how they change the equation and how they change the outcome. And I believe this is all that we have to mention from this scene. Let me check if there's any other important scripts. I will show you jump scripts one more time, just to clear some things. And in this function, since we use get key down function, we have to check this inside update. And if get key down is pressed, we record this inside a Boolean parameter. So if space button is pressed, should jump will become true. And inside fixed update function, if our object should jump, then we add some force in this direction. So we add a force in the up direction, and also we set should jump false, because we don't want to jump again. We don't want to let our object jump infinitely. So this is how it works. And this is all I wanted to show you from this part. If you don't have any other questions, I want to go to the next type of movement. Okay. By the way, I know that I talked about rigid body physics in our previous lecture, but still, I just wanted to show you the results when you freeze rotation in X, Y, and Z axis. So yeah, this is why I added. And in this section in the scene, I can also turn by moving my mouse. I can move by WASD keys, and I can also certainly I can jump. I can even double jump. I can even jump infinitely. Yeah, so this is what we have, and let's check what we I mean how we achieve this effect. So it's not too different currently, but there are some little differences. So we again have the same script which clamps our velocity and doesn't let us move if we are too fast. And we have the jump script again, and also we have rotate with mouse again. So I mean, technically they do the same thing, but now we have a capsule collider instead of mesh collider or cube. Basically, instead of a cube, we have a capsule. And is there any other difference? I'm going to check it. So I guess no, but I wanted to. Yeah, it's here. Okay. So the scene is named rigid body character, but unfortunately there are no character controllers or something here. So I'm checking what's the deal. Yeah, I guess it's the reason there's capsule collider added is because you can do stuff like this. If you focus this character controller in scene, for instance, you can check, so you can change the radius of your collider, and you can change the height as well. So the reason you might want to do that is, for instance, if you have a flying character or if you have a gliding character, like a surfer, for instance, and like some kind of silver surfer character that glides on top of the floor but does not touch, but it does not fly completely. You can have your objects have a bigger height like this, and if you click it, then your objects will look like as if it's flying, you know. I mean, it's not actually flying. There's a collider, but since you don't see it, it acts like it's kind of gliding on top of something. So this is a pretty easy way to have gliding objects. And I'm checking if we can add something to that. But yeah, this is all, I guess, from here. And I want to move to, I'm not going to save this change. I'm going to move to character controller scene. which utilizes a Unity feature called CharacterController. And now we have, we can add a CharacterController by writing CharacterController here. This is a Unity component that is created by Unity. We just have to add it if we want to use it. And it's basically an extended form of rigidbody, okay? So a CharacterController does what a rigidbody does, but it lets us worry about other things in our code, because it takes care of some things that we have to write if we want to use rigidbody. For instance, if you want your character to walk in stairs, CharacterController is a good way to achieve that, because let me just show you. So now I'm not jumping, but as you see, I'm able to walk in the stairs, but there's a limit to that. So for instance, I cannot walk past this cube, you know. Oh, actually I did. If I move from the corner, I'm able to do that as well, actually. But you can limit the movements. For instance, I cannot move up this wall, but there's a certain threshold. If the difference between two surfaces are below this threshold, I'm able to move past this this part, you know. And if there was no CharacterController, then we would have to write some code that takes too much time. So instead of this, you can basically use a CharacterController, which you can modify the parameters. For instance, if you change the step offset to 0.2, then you will probably be able to move this stair as well. Oh, okay, it's still not possible, but let me just make this a little bit higher and see. By the way, the reason we are not able to move to the third stair is because there's a bigger difference compared to this difference. So this is why I'm not able to walk. So I'm trying to lower the threshold. Yeah, and now since my offset is bigger, I'm able to move on top of lots of things. Yeah, I mean, I don't even have to use the first stair anymore. I can just walk like this, and I'm able to go to the second stair without even pressing the first stair. And I also have the jump function, but I'm not using my jump function. I'm just climbing, you know. But I'm going to make this back, and now as you will see, I won't be able to. Actually, I'm still able to. Yeah, sometimes. Okay. So if I come from this direction, this left direction, I'm able to jump not jump, but I'm able to climb to the second stair, but I'm not able to climb to the third stair. And if I move like this, I'm not able to, I'm not easily able to climb to the third stair. It's based on the corners. So when you are trying to climb from the corners, it sometimes lets you climb, but you can change the limitations by messing with this step offset. And also you can change the slope limit. So slope limit is when you are trying to climb. So let's say that you have a, let me just show you a paper. So, or this is a picture better. So when you have a surface like this and your character wants to move up this surface, then you need to define if it's able to move or not based on this slope limit. If slope limit is 45, then if your angle is more stiff, then your character won't be able to move on top of this mountain, for instance. But if your angle is like 30 degrees or something, since your slope limit is higher, you are able to easily climb. So to show that, I need to add something inside this scene. So I'm going to add a 3D cube like this. It should be bigger. And it should be rotated a little bit, not in this direction, but in this direction. And now we have a mountain. So let's move it like this. Let's do this 45. And let's move it like this. So, okay. So if I now hit play, I guess I should be able to move on top of this. Oh, okay, it's not. But let's change my character controller's slope limit to 50. Okay. I should be able to climb it right now. Yeah. So you see the difference? Even if it's something like 46, I should be able to climb. Let's check that. Yeah, I'm able to climb. So enabling this kind of movement is pretty simple with character controllers. And if you have a terrain that accepts mountains or stairs, then it's a good idea to use a character controller instead of rigid body. Okay. And I'm going to change my scene. Sorry, I'm going to save my scene, and I don't remember what is skin width, but and this minimum distance is, I guess, the smallest step that you can take. So when you click forward, you go at least this amount. Is this amount? I'm going to actually change this number to have a different effect. Yeah. So now even if I click it one time, I'm not able to move. I should hold my mouse button. So it says that if you don't move by this amount, I'm not going to allow you to move. So this is changing the sensitivity of your buttons, basically. And it also has the radius. Let me just focus on my object. It also has the radius, which I can change, and it also has the height. I mean, it's kind of hard to see, but if you look at it from this angle, you can change the height of your object as well. Let's leave it in 2 for now, so it matches the height of the capsule. And we saw this script, which we use to rotate with our mouse position. And I'm going to also show you 2 different scripts. First of all, I want to show you the SimpleMove script, which uses the function which is inside our CharacterController class. So this SimpleMove is a function within the CharacterController class, and it moves the character with the speed. So you should give a speed inside it. So now we need to define our speed. So we get 2 inputs, one in the horizontal and the other is in the vertical axis. And you create a vector that you call direction, and you use the inputs that you are given. And after that, you calculate the movement vector by using the direction and also the move speed that you have defined here by hand. And this transform direction function is basically transforming direction from local space to world space. So if you I mean, even if you calculate local space, this transform will be moved as like reference to the world space. And after that, if you use this SimpleMove function, then it will just move it, and it will return if your character is touching the ground or not. And by that, I mean, you can check if you can jump or not. Let me just show you. But first I'm going to see what is the case with that. So step offset must be less or equal to scaled height plus scaled radius multiplied by 2. Okay. So I mean, what is my scaled height? It's 2. My scaled radius is 0. Multiplied by 2 is, I guess, 2 or something like that. So I mean, I cannot change this below or above these thresholds. Okay. And if we open a new game, I want you to focus on is grounded method. So for some reason it's not updating, but it should be updating. So it's not updating because I'm not using my SimpleMove command as SimpleMove script. So now I'm going to check this one and uncheck character move script. We will get to this later. They achieve the same results, but in different ways. So now, as you see with character SimpleMove script, I'm able to do basically the same thing that I was able to do. Yeah, sometimes it does not collide as it should. This is because my capsule collider is not big enough. And to change that, I guess you need to make your collider a bit bigger. So maybe the radius should be around 0.5. Now I don't expect any weird collisions. Yeah, now it looks normal. And also, again, I'm able to climb this without any problems. And SimpleMove works like that. If you see this is grounded Boolean, if you are touching, this is Boolean is checked. If you are using the SimpleMove button, sorry, if you are using the SimpleMove function, and if you want to jump, or if you want to fall down, for instance, when you're falling down, it gets unchecked. So let me just show you one more time. So I'm going to fall down. If you see is grounded, it will be unchecked for 1 second or something like that. And when I touch the ground, it's checked again. And when I'm falling down, it's unchecked. So you can disable jumping if you are not touching the ground, for instance. This is a nice way to utilize this. Currently, I'm not using this Boolean in any way. This is just to show you that it's quite easy to check if your character is touching to a ground or not. Okay, and now I want to take a look at the character move script. So we actually saw how this works. It works basically the same to character SimpleMove script, but it utilizes another method, which is move, not simple move. So in SimpleMove, even if you are working in fixed update, you don't have to multiply this by time.delta time. But when you are working on move script, sorry, when you are using move function, you need to take time.delta time into account. So what this does is taking two different inputs, calculating an input direction. If you notice, it does not interfere with what is happening in the y direction. This is because y position is determined by our jump mechanic. So now we are trying to move our object in x and z directions, and your transform direction will be calculated as transform direction input direction. So now you know which direction your transform will be going in. And after that, you multiply this direction vector by move speed and time.delta time to get some smooth movement. And now you have your movement vector. But this is how much you want to move in this direction, not including the direction itself. So now you need to get flat movement x and flat movement z to calculate smooth direction. By the way, your move direction y is calculated somewhere else. It's calculated here based on the jump mechanic. So if your character has jumped, this y parameter will be calculated as this. If it did not jump, it will be basically 0. And your move direction will be calculated like this, as I told you. And after you calculate your move direction, you basically use character controller classes move methods, which is a more complex move function taking absolute movement deltas to have a smoother transaction, you know. And with that, I mean, you need to give a motion in this method. And after that, you are able to move your character controller. By the way, if we check here, there's a Boolean that checks if our player has jumped or not. And this is using, I mean, this is checking if user has pressed space. And also it is checking if our character controller is touching the ground. If both those conditions are met, then player jumped will equal true. And if player has jumped, then my move direction.y will be equal to jump speed, which we declared here and also in the editor. Else, if my player didn't jump and it is grounded, so it's touching the ground and it did not jump, it won't change its position in y direction. And if my character did not jump, but it's not also touching the ground, so if it's in the air, then it will be moved based on the gravity vector, you know. So I declared, I mean, gravity in as 2. So this line specifies the falling speed, basically. And I declare my move direction .y here, and I give my move direction y here. So you might say that the change, I mean, the order should change, right? So like here. Sorry. So you might say that this part should be on top of this line. You are right, actually. But even if I write it the other way around, it will work because this fixed update method gets called too frequently. But this is a better method of writing. So I'm going to actually change the order and see how we move. So we are moving same way as before. So it did not affect the game, but it's a better way, you know, to calculate and use the same variable in the same fixed update. Because if I don't do that, if I calculate this below, then I will save this move direction.y to somewhere, and it will be used in the next fixed update method, you know. So yeah, this is what I like to cover in character move script. I want to give a break of 20 minutes, and after that we will see some other methods of movement. Okay.
Okay, see you.
See you.
See you.